Welcome back to another video. I'm building the DC-load, designed by Scullcom Electronics. I did this a while ago. I ordered parts. I ordered a box. The box was too small. I modified the board and the display so it all fits. And I will show that in the video. And you should check out this channel. If you like to know how the thing is designed and the parts he has used and the evolution of this board, and I really recommend you to check it out. I will put a link in the description. But now this video is like a build log, and now you get to travel back in time. Don't know if you can see it. It's this little guy there, and also if you look here, you have a different chip, but this one has the correct package, SOT23-6 for the footprint. But this one I bought something called SC70 package, so I had to do my best to make it solder, and that's a 12-bit DAC. Can you believe it? So small. Here's my finger for comparison. So small. Okay, I managed to get that wrong, but this is the DAC, and this is just an inverter. But anyway, DAC. You have the Arduino over here. A DAC usually just take a digital signal and then puts out a voltage or a set point. And then the set point is buffered, and it drives the MOSFET. Basically what you're setting is it is setting the current. So a voltage here becomes the current, right? And to read back we have a analog to digital converter. So you can see we are regulating this path here. This is negative feedback. But at the same time we are also taking that value here that is regulated and feeding it back into the ADC such that we can read. Just wanted to say that because these packages are really impressive how small they are. So, and you can see we have an analog devices here. Let's have a look at that one. Yeah, okay, so that's a package of operational amplifiers. So AD8630. You can see more of them. There's S7A, 7B, U7B, U7D, and you have a U7C. So I think there's 4 in one package though. So not exactly sure what it's doing, but it goes into channel 1 on that ADC, while the other one was the current measurement. So this must be maybe a voltage. So let's have a look. Yeah, so that's the voltage measurement. So it comes over here, basically. So that's it for today. So let's continue next day. And it's very tempting to put these on right now, but they will be a little bit up in the air, and I'm going to move this one around a lot now when I work on it, and they will get bent, so I will wait with that. So yeah, so it's getting there. It's a few components, and I'm waiting for that one also because I ordered the wrong voltage reference. I ordered 2.5 volt when you need 5 volt voltage reference. So yeah, that will be in the mail soon. So cut away the part I don't want, and now I can see that these nets are not connected anymore. So I just scratch here, and solder a wire. Should be fine. Made a 3D model of the project, and I need to cut away this much to get it to fit, so I marked it. And you can see I need to join these two nets after I've done that. And also here I think something will need to be joined on the other side. Probably fine. There we go. And patched up. So yeah. Now I can fit the thing down in here, so that didn't go so well before. So there was no space anymore, so yeah, there you go. Cool, now it fits. Yeah, so this is for today. This is what I've done, and well. So what I decided to do was to do something funny. Use one of these boards, because I get 3 of these boards, so why not just make one out of them. So, there you go. And there you are. That's not too bad. But it's really hard to get those holes straight over here. So I tried to use this as a guide, these holes, while I'm drilling, but I found that it was easier to just press the drill hard. Not too bad, is it? Okay, so I need some... doesn't fit there anymore. Yeah, but I'll fix that. So I was thinking, there are some packages here that need cooling. So what if I can pull wires from them up here and have the cooling system inside the box instead of outside? That would be nice. But what is required of me then? So let's have a look at the schematic and then the... So here's the board. Let's look at the 3D model. Alright, so you can see here, these are all the packages that need cooling. You see them all placed in a flat line. This is the input, this is the output over here to the load. So basically current goes in here to the fuse through a diode, divided into 4 current paths with MOSFET transistors through some load sharing helping resistors, and then finally through a current sense resistor. This guy over here is a temperature measurement LM35 device, so we can turn the fan on or off. And that's basically it, and then the current goes out again here. So there are no large currents going out here, and I will explain why. This is my fourth take of this, because I need to explain it properly. So yeah, but what are the implications? Okay, so this is the same package as this, just the wrong 3D model. And you can see it down here. This is a 100 milliohms resistor. Yeah, sorry for scrolling all that. So all the current is dumped into this big net and then out again here through this resistor. So you can see it's collected, all those four, 1, 2, 3, 4 resistors there goes into the same net, which goes back to ground. So that puzzled me a little bit, because when I looked at the schematic, I was thinking of how can I reduce error if I take a current resistor like this one down here and put the wires on it, because it's 100 milliohms, and if you put a wire and 2 wires on it, it becomes 200, 300 milliohms easy. So the error is really great. So that's not good. Great is not good. So yeah. So what can we do? I was thinking 4-wire arrangement. So yeah. So let's go in here. It's a bit overexposed. You can see on the top there, top right, the load, the fuse, the protection diode, divided here into a regulation loop. And the regulation loop keeps these two inputs the same. This one is fixed by a DAC, which is controlled by the microcontroller over here by I to C. Sets a value. It's buffered over there. It's calibrated over here, and then what you're actually regulating is the sensor resistor voltage over there. To reduce the error after adding resistance or adding wires on that resistor, I need to know where the current goes. We want to measure here, we need the ground reference to be the same as the load. So here is the negative output. So the positive one is that it's here. So all the current goes through here, creates a current sense voltage here, and it's pulled out here, as you can see. It's still the same net, you see, net D3 blah blah blah, it's the same net name, but it's pulled out at a certain point. Could have been pulled out here, right? But then you introduce error, because then the current will be measured, or the current sense will be measured over here, which has a higher value than it leaves when it leaves out here, because everything has resistance, and if you have a current, you have a voltage drop. So, and this is the only known value. It's a known value with a known tolerance. So here you know it's 100 milliohms plus minus something. So then you want to measure it right where it is. So what I'm thinking of doing, I can cut here, make a cut there, and then pull a wire down there, which I know doesn't pull any current. It only feeds the voltage from that resistor. How about the negative? So I was a little bit puzzled by this, because I know this is ground, so it's like common ground. The negative product is connected directly here. So we know all the current, or the large current anyway, that will cause a large error, it goes out here strictly. It's a very short path. It doesn't go this way, right? It goes directly back to the load, because current comes in here, then through all of this, and back to the load out there again. So yeah, so maybe I should make a little cut here. What do you think? Does it make sense, such that I can draw a wire down from the sensor resistor as a 4th wire? I have to try. I can try with and then without and see if there's any difference. But however, here I think I really need to do it. But so I'm about to program this board, and I have downloaded all the libraries inside Arduino. It's very easy. Use the manager. And for the libraries that are not in the sketch or are a different version than which are in the sketch or the library manager or Arduino repository, you have to install manually. So that's fairly easy. Go to menu, include library, and add the zip file. And in the code there's links to those zip files. That's great. Now I did install the liquid crystal I2C, but I didn't install the new liquid crystal. So what happened was that I got an error that said the prototype length wasn't long enough. Okay folks, I can show you. So basically just hit compile and see what happens, and then it says okay, you're missing something here. Yeah, so you can see what that error is. It's not that important right now, but it says it doesn't have that file. Okay, so what I did by mistake, I didn't manage in here, sketch, manage libraries, liquid crystal. Anyway, I installed that one, I think. So let's try that, see what happens. Hit compile. Now it says it doesn't have this function because there's a call in the program that has like parameters. So then I just went in and did like sketch, include library, my zip file, and I downloaded it, and I hit compile again. And then it says no matching functions. So I was scratching my head and I was thinking, why doesn't this work? Well, there's also a warning here, multiple libraries were found. So it doesn't know which one to choose. But then you can go into your Arduino libraries folder. And now I have this one, but I also have this one. Work into this. So I remove this one, and then the issue should be gone. And then let's try it again. And there we go. Yeah, so after a bit back and forth, I had to solder in the 12 volt regulator and 5 volt regulator. Yeah. So if I switch it on now, there's light, but I also had to add a jumper here. But I can't see anything, but maybe you can see from a different angle. There's something there. So basically what we need to do is to adjust the contrast, I think. So let's try it again. Not too shabby. Yeah, so this is a program for using the numpad, which I do have here, but I'm not planning to use it because there's no room for it. So it seems to be working without power also, just from the USB. So, but then the contrast is off. Okay, I ripped out the part of the code which has to do with the keypad, so now that's working. Also over here you can see I have a LM35. Now you can see the readings are going high wire, but if I put it back in again, it comes down. So, and another thing I did when I removed that keypad over there, I get a lot of IOs free here, so so I connected that up to the LED. It's actually LED in here, which is actually 12 volt, but it works on 5 volts, so I figured just for now I can change it later, but look, that works. So it says load on there. Maybe I can free that to something else. But yeah, so anyway, it's not working now, so you can see I can move the cursor here, and that's about it. So yeah, so I need to figure out how it works. I need to change the mode. This is constant current mode. So yeah, so it would be cool to see if it actually is working. Yeah, also I have disabled the over temperature thing, because now if I reset it, you can see here temperature limit 0, so it will not work for now anyway. So I've been working on the code for a while now, for a day or so, and it's a lot of things, so I will go through that later, but it's easier for me just to explain what I'm doing right now. So if I go to the display, I have a faster display now, and it separates between short clicks and long clicks. I also have a debugger up here. So this is the serial output, short presses and long presses. Everything above 500 is long press. So that's working. So I basically just made a function, load button, and then if it's a short press or a high press, it does separate things. So yeah, so what I've been doing with the code, let's talk a little bit about that. You may pause the video here if you want to see my load button function. It's a bit hairy, but it works. Yeah, so while I'm tapping the camera again, let's talk a little bit about what I've done so far. So the key things I've done, I've removed the keypad, and that will free up some IOs for rotary encoder and a indicator inside that switch. So you have the indicator, reduce the screen updates. The screen updates are slowing down the loop time. So and also another problem was there was floats used in the interrupt service routine for the rotary encoder. So I'm using just regular 8-bit variables, so you don't even need that, but just to make it as fast as possible so you don't lose any counts. Then you have the interrupt on falling. That makes I break the code, so I need to code it better. Interrupt on falling, it was on low, so that meant if I turned the rotary encoder such that one of the IOs got low, it just interrupted constantly. So the rest of the program just stops until you turn it one tick to the right again or left. I don't know why that was. And then you had an ADC which was blocking. So that means it took like half a second just to read the volt and the current. And then the rest of the code, the user interface was just blocked. So if you press the button, you have to like wait for the user interface to come back and read it and stuff. So, but I found a non-blocking version in just looking at examples. You can find it. So here is convert non-delay. So it says something down here how you could do it. Like you need a state machine though, or two states. One to start conversion, and then you supply a config. So there, in my program, there are two configs, one for voltage and one for current. So, and you keep since the loop I'm having in the program for the user interface, it will then pull this function. So basically just pulse, and then until there's no error or is ready, it collects the value, and then the cycle repeats, so that's funny. Yeah, so that's basically the things I've done. And now I'm starting to rewrite a lot of the code so to accept the new user interface. A lot of the stuff that is there from before is working. Right now I'm dumping the camera, so I think I can show you something that is working. It's kind of spooky, I don't know. By the way, why did the display turn black? Because I'm dumping the camera and I took out one of the plugs there. Yeah, so alright. Okay, alright. So now we have a current reading here. There are no transistors there yet, so there will be no current. But somehow it's showing it anyway. Sometimes it's just 0, but it's not calibrated. However, look, now I have 5 volt there. If I turn it on and it's connected to the sense input, the whole thing just froze. That was not supposed to happen. Yeah, so I need to figure out what's going on here. So there it's back. Alright, look, 499. So if I change this value, see it follows. Let's see, 4.00 3994. It's really close. I really love that. So if I this power thing, I can only lab power supply. I can only turn 10 millivolts at a time. So you can see it's a bit how we're doing. Yeah, but that's the power supply probably. So I haven't tested it against a voltmeter yet. So yeah, so that's cool. So now I need to focus on my file transfer. So I was programming all Saturday, now it's Sunday, and fixed a couple of things, reading long and short presses on both the switches, so I can use it in the code, so don't have to think how to do that all the time. I have removed more blocking code, so now it's very responsive, as you can see. Also, now this button is load on and off with short presses. It didn't used to be like that. So if you hold it in, the load goes off and you get a menu here, so you can skip through. Battery capacity test, constant current, constant voltage, hold it in and you have constant voltage. So, but let's go to constant current, like that. I fixed the rotary wheel, so now it's in coarse mode. It's not perfect. I can go fast. Then if I click it, you get into fine adjustment. So click it again, it goes into coarse. So turn on the load, and that's basically it. So the next thing to do now, before fixing the rest of the code, is to make the CC mode work. Now I don't know why it doesn't say CC here, it's supposed to do that. So let's see, it says CC. Yeah, sometimes it goes away. Anyway, so that's the update, and yeah. There's the 3D model, and you can see it's like very much the same. So before I put it together, I thought to show you what I plan. I plan to have a gutter fence here, or a mesh. Yeah, so you get air intake and maybe make some more holes at the top, or cut out a piece here maybe for the fan. Not sure about that yet. hide this for a moment. I think this is not in focus, so yeah. So there you got the fan. It's hovering in there. Let's just remove that for now. You can see the board. So yeah, and down there you can also see there's two connectors there. They go into this other connectors. So that doesn't work. So what I've done, I have desoldered them and then moved them out. That's why you can see it like that, such that I can have these little guys here. Yeah, so that's why I did the 3D drawing, because I didn't want to make so many mistakes, but I did them anyway. So anyhow, so let's see, bottom, enclosure, bottom, hide. Let's see. So yeah, so that's basically what I'm going to do. That's the rear part assembled. So let's see with the front. This goes in here. Let's see. There's a tight fit. If you look closely, I'm trying to look at the camera at the same time, you can see that I maybe need some isolation here. But yeah, well, the cables are making isolation. Yeah, so also you can see it's very close there, but it does work, I think. So let me just mount that. So there you go, proof that I'm not completely useless. And put the cover on. But first I think I need to pull out some cables here. So I can take the there. Now the load LED will not work because I haven't connected these guys. They are so terrible anyway. So that's okay. Need cable management also. This cable is sticking out on the side here. But that's basically what we have. So I cleaned up the table. I've been having a vacation for a week now. So I've been snacking a lot and a lot of a lot of dust everywhere. So lazy. Oh, this is cool. And nice having time off so you can do other stuff without getting stressed out. So what do you think, guys? Looks promising. There's not supposed to be a cable here. It's supposed to have an 18-volt power supply. But now for debugging that will be working, so yeah. Alright, thank you very much for watching. See you another time. Bye bye.